Would you say that beyond line of sight definitely has a priority over line of sight testing and operations?
So actually in our work it's the other way around. Line of sight, so it depends on how you think of line of sight. Mm-hmm. If line of sight is the operator looking at the vehicle, that's not what we mean by line of sight. Okay. Line of sight is the communication pathway. So terrestrial communication where you've got the aircraft pilot is talking through a system where it's line of sight to the transmitter. That's the area that we're focused on.
That's right. The other term is that I'm thinking of actually is visual line of sight.
Visual line of sight
okay.
is not where we're focused.
Okay.
We're focused on line of sight versus beyond line of sight from the communication standpoint. In other words, terrestrial-based versus satellite-based. Yeah. So right now, the terrestrial-based side of the house is where there are some frequencies that have been allocated by the World Radio Conference, which happens about every 3 or 4 years. It all depends on how they line it up. Mm-hmm. Is part of the International Telecommunications Union. Okay. And so that's where a lot of the sausage gets made in terms of frequency allocation. And so in the last one, which was 2012, the WRC 2012, that's where certain segments of spectrum were allocated for safety of flight operations for UAS. I don't have the specifics, but it's somewhere around in the 1,000 kilohertz range, I think, and then in the 5030 to 5091 megahertz. So I'm pretty sure that that's the right. But those are the spectrum frequencies that were allocated. We're building prototype radios in those frequency ranges to be able to test to make sure that, in fact, those are valid frequencies that can be used for that are scalable and secure, et cetera, for UAS operations.
What's the range looking like on some of these as far as how far you can communicate and maintain a link?
Well, so these are terrestrial based. So yeah. Again, it's that line of sight operation. Mm-hmm. So it's not the beyond line of sight over the horizon. Yeah. And so, you know, from that standpoint, looking at the number of ground terrestrial based sites is part of the work that we're doing. Mm-hmm. To see how many it would take and how many unmanned aircraft you're going to actually be able to control in a given frequency band. Yeah. Because as the proliferation of unmanned aircraft that theoretically, you know, is going to darken the skies, as they say. But as more and more unmanned aircraft are introduced, the question is how many of them could be on that frequency without having it be disrupted. Mm-hmm. And that's part of the research that we're looking at. So that could drive how many terrestrial-based sites there are, based on the type of airspace you're talking about and the number of unmanned aircraft that'll be in it. So that's all a work in progress.
It could be relative, maybe in size and distribution to radar control systems that are in place already, in the sense that radar detects aircraft and communicates to the air traffic controller where aircraft are. And that deals with also the limitations of range of radar. So in that same sense, you'll be testing it as far as the communications range and deciding how far you're going to have to place.
Right. How far, and some of that might be based on how many aircraft. So all that is part of the testing regime that we're coming up with. So then we can take that information, that body of evidence, that data collection, along with the candidate radios and how we did it, et cetera, and give that to the standards organizations, the World Radio Conference, SC203, which is part of our TCA, for them to then come up with recommendations for what the standard should be, so that someone can build a system that meets those requirements, someone being primarily industry.
Will it eventually involve the FCC at all?
Absolutely.
Yeah?
Yeah, and it already does. I mean, they're already part of that discussion. On the satellite-based side, right now, there really aren't very many frequencies that could be used, and there really aren't satellites that have the radios on board to be able to communicate properly.
Except for the military.
Except for the military, right. Yeah. So when we're flying our NASA vehicles, sometimes we'll tap into that. Yeah. But generally speaking, we're looking at, from the standpoint of communications, a terrestrial-based side. And so that's a long pole in the tent. So you could solve all the other problems, and if you don't have a frequency to do command and control, you can't fly your aircraft. Because it's not like, you know, it is for voice communication with a pilot. There has to be data transmitted, so it has to be in these particular, you know, spectrum ranges that have been allocated by the World Radio Conference.